So for our agenda, we're going to be talking a little bit about the basic reasons on why we're filtering the air, some guidance and considerations that we should be using in the current situation that we have going on with the COVID pandemic, and then some filter conversion options that are available to us when your customers are looking for higher efficiency grades of filtration. And then after that, we'll be talking about different filter sizes and availability for those products to serve your customers. So the main reasons that we're filtering the air as an HVAC filtration is we're trying to remove contaminants in ambient atmospheric air, which can be contaminant that's generated indoors and also outdoors. And that may be a percentage of circulated air coming in from outdoors and then also from inside. So either or, outdoor or indoor, you're going to get particulate into your building that can circulate the HVAC system. So the filters are there to help mitigate that. The three different classes that we talk about when removing matter from the air is airborne particulate matter, gases or odors, and then microbiological contaminants, which is a lot of consideration today under COVID. Generally, microbiological and airborne particulate matter are both treated as particulate. So you're looking for particulate efficiency filters that are normally classified by a MERV number or a MERV efficiency. Gases or odors are normally handled by gas phase or what's known as carbon or charcoal products, as you may be more familiar with. What you see in the table on this slide is there's a large range of mean particulate sizes in ambient air. But the main particulate that you're really concerned about these days with COVID is 3 microns and smaller are generally your representative sizes of airborne bioaerosols that may carry or be a transport mechanism for viruses and bacteria. Viruses and bacteria themselves can be quite small, but they typically ride on another particulate, particularly one that's generated when you sneeze or cough. Over the past few months, I'm sure you've seen, there's been a lot of guidance on COVID, and there's been a filter efficiency guidance on COVID that's been produced. So several organizations have provided this. One of the ones that are central to our industry is ASHRAE, which has offered several different guidance letters during COVID on building operation preparedness and position documents on infectious aerosols. This is also being shared by the CDC, which also has similar types of guidance available for people. So these links are here on this slide for your convenience, but I would suggest to you that keep these links handy and refer to these sites for additional COVID information, because as you might have seen on the news, information changes sometimes on a weekly or daily basis. So these sites would have the most up-to-date information on COVID and the guidance that are out there by various organizations. So what you're going to have with the current pandemic and the current situation is that you're typically going to have people looking for MERV 13 and higher filters. This is the current guidance from both CDC and ASHRAE. In some systems, that makes it possibly a little bit difficult to make a filter conversion. There's a lot of multi-stage systems out there and a lot of single-stage systems out there. Multi-stage being shown up in the upper right-hand corner. You could have 1-stage and 2-stage filters. In those kind of applications, it's probably fairly easy to switch over and switch your second stage to a higher efficiency filter. There are a lot of options available for that. But there are many commercial applications that only use a single filter stage. And typically those type of systems are designed to operate with low to mid efficiency filters. So that would be your MERV values between 1 and 11. Could be anything from a disposable fiberglass filter all the way up to a pleated filter. And those are where we're seeing a lot of demand for customers wanting to improve those single station systems to a higher MERV efficiency. So, which can be done, but there's a lot of variables that have to be considered before you want to make that type of filter upgrade, because changing the filter efficiency can have impacts on the effectiveness of the system. And those impacts can be the filter resistance to airflow, system bypass, and system service life for the filters. So the first consideration is filter resistance to airflow. Generally speaking, as you increase filter efficiency, you will also increase that filter's resistance to airflow. Most commercial systems are designed, for single stage, are designed around a maximum filter resistance of 1-inch water column or higher. And in those systems, you can handle that additional resistance to flow in most circumstances. However, there are light commercial or ventilation units, which are really designed to move air and not really designed to handle high efficiency products. So in those kind of applications, the maximum filter resistance might be a 1/2 inch or lower, which can cause air restrictions and then cause complications to either restrict airflow or even possibly damage HVAC systems and components. So examples of these would be light, low tonnage air conditioning units, something you might see more in residential applications, all the way down to, for example, some hotels which may have wall-mounted ventilation units and not a central air handler. Those were the ones where you would have the most risk. So when a customer is wanting to go and improve filter efficiency, the first thing that needs to be asked there is to try to review their system specifications, what kind of filters, what kind of airflow rates it can handle before making a change to a higher efficiency product. The second is air bypass. Generally, again, as you increase filter efficiency and you increase resistance, you also increase the potential for bypass. And what bypass is air that leaks around the filter, does not go through the filter media. And anywhere where the air leaks around the filter, that air is not filtered and therefore contaminant can bypass that filter. So it makes it less effective in your HVAC system. Primary reason that happens is poor sealing or seating of the filter in its frame or track system. If you don't have the filter properly seated, sitting flush in the track or against the frames, then it can be sitting in an angle and allow bypass. Or if that filter is fitting loosely in the track, you can end up having bypass. So when looking at improving efficiency, you might want to also check the filter frames to see if they're in good condition and to see if gasket might need to be added as an aftermarket step. So gaskets are readily available in a lot of hardware stores. Some of your sites may have gasket available or weather stripping, and those kind of materials can be used to help gasket tracks and get a better fit and seal for the filter. Finally, air filter service life. With higher efficiency filters, they will collect particulate at a higher rate than what a lower efficiency would see. So it is possible that that higher efficiency filter could get to its end of service life faster than a lower efficiency product. It's essentially doing its job by catching that smaller particulate, but again, it loads faster. So the way to go over and combat this is the best way is to install HVAC filter gauges. These can be magnehelic gauges, they can be water gauges that measure the filter resistance in system. In those kind of cases, you don't want to let the filter resistance rise higher than what the HVAC system that can handle. If gauges are not used, then generally people would make a change out on air filtration based upon a noticed reduction in airflow. If you're not feeling as much air coming through the supply side of the system, or if your longer periods of heating or cooling is going on, or you're not getting enough cooling in a space or heating in a space, that may be an indication that the filters are ready to be changed. From here, we're going to go into several different scenarios based upon types of tracks that you see in light commercial systems or single stage systems out in the marketplace. So the first is talking about 1-inch depth product, which is going to be very common in your very light commercial systems. Typically, what you're going to see in those systems are disposable panel filters, fiberglass, could be polyester or could be fiberglass. You could see ring panel filters. You might see MERV 8 or MERV 11 pleats as well. For these type of applications, you have basically two options for a higher efficiency product. The main go-to in that case would be a 1-inch MERV 13 pleat. That's in the gold on the right-hand side, followed by potentially a 4-inch single header filter, which would be the Parker Load Tech, assuming that you have enough room in your system to accommodate a 4-inch filter with a 1-inch track. The point that I'm making about small unit ventilators is when you look at the disposable filters on the left-hand side, that product typically has a half an inch final resistance to airflow, where many of the others have a 1-inch final resistance. And you can see that the disposables generally range from an initial resistance of 0.07 to 0.14 inches. To move to a MERV 13 on these low-end systems using low-end filters, you're looking a significant jump of several times over a resistance to airflow. A typical MERV 13 pleat will have an initial resistance of 0.43 inches water column at 300 feet per minute, so a big jump. A Parker Load Tech 4-inch is a little bit better off at 300 feet per minute, has an initial resistance of 0.28 inches. But are in these applications where you have to take the biggest care in moving up to a higher efficiency product. You want to make sure that the system can handle that higher resistance to flow in the MERV 13 pleat and also in the 4-inch MERV 14 if possible. There's a situation where if, for example, with the MERV 13 pleat, if that filter system can only handle up to a half-inch water column with the fans, then you could quickly run into an overload situation with that particular system. So care would have to be taken there to review that. In single stage conversion for 2-inch depth, you have far more advantages and options available to you. Typically, again, in 2-inch systems, you're using either a 2-inch disposable or 2-inch pleated filter or either MERV 8 or MERV 11. So options available to us in 2-inch are, again, the 2-inch MERV 13 pleated filter or Puro Green, a MERV 13 mini pleat, which is our Advantage, and then also, which is also available in MERV 14 and 16 as higher efficiency options. Here in systems with 2-inch filters, you typically have a more tolerance for higher efficiency filters. Usually you'll have bigger fans capable of handling that load. But again, you'll want to double check that because initial resistance on a disposable is again 0.09 to 0.14 inches, where MERV 13 pleat is going up to 0.37 inches, so more than double initial resistance. So you'll again want to double check and make sure the system can accommodate that higher resistance filter and still operate properly. But again, you have a lot more options available to you in changing out for your 2-inch product. Finally, probably the more rare instances that you might run into, but you might come across some 4-inch pleats in a single stage. Here, you mainly have two options to go with. That's going to be either a 4-inch Parker Load Tech or a 4-inch MERV 13 pleat as your options. Here in 4-inch, you're typically not going to run into a whole lot of efficiency or resistance issues with the system. They're going to be more able to handle that. But there is a resistance increase. You're going from about anywhere from 0.15 to 0.19 inches water column on a MERV 8 pleat up to 0.3 inches on a MERV 13. So again, something you might want to check into to make sure that the systems are compatible before making that change. To kind of give you some idea of what the products are as far as for options, the first product would be our Puro Green, which is our MERV 13 pleat. This is in many cases going to be the lowest cost option for a retrofit. This will operate similar, it's a MERV 13 pleat, so similar format to a MERV 8 or MERV 11. It would be easily retrofitted into most systems without having to change any tracks. It will have the same construction as most MERV 8 pleats out in the market. So not a lot of need for retrofit or any other type of repurposing there to use that. The next higher up product from that is the 2-inch Parker Advantage. These are typically mini pleat filters. So these are more expensive than pleats, but they do have higher overall performance. They have generally a good resistance to airflow, higher capacity to hold dust. They typically can operate longer under certain conditions on that. And what you can also get with that is reduced space and storage for lower shipping costs. They do have a lot of good energy savings and they're very compact. So a good performance option if you want to step up from Puro Green. Finally, there's the 4-inch Parker Load Tech. Again, you're going to have limited areas where you might use this. It's where you're going to have a footprint to use for a 4-inch filter. But with this product, you're going to get the best overall performance. It's going to be designed for low pressure drop at high rate of flow. So it's going to give you a lot of advantages in adapting systems to these higher efficiencies. These kind of tracks are used in a lot of different applications, such as building, schools, and universities. So if you're selling into those kind of markets, these products might be a key for you to go ahead and use going forward. With this increased performance, you also get, again, lower footprint with these products, selling it out to the market space. These filters are available in all sorts of different standard sizes, most standard sizes to accommodate most systems that you're going to see out in the marketplace. DP Green, this is an example of the MERV 13 pleat and the availability in standard sizes. So you shouldn't have much of a problem in finding a size that will work for a system. If your system is different or requires a different size filter than what's on the left, these products can be offered in custom sizes. So if you need something off size, you can use your catalog or talk to your reps, and then they can go and help you get the right custom size application for your system. For the Parker 2-inch Advantage, we do not have custom size capacity available in this product line, but we do have a large range of products, again, in most standard sizes you would find in HVAC. So from the lowest efficiency MERV 8 all the way up to MERV 16, we should have products that fit most HVAC applications that you would probably run into in the marketplace. Finally, for the Parker Load Tech, this has the lowest availability of sizes, and we, again, do not have custom size capacity. But we do have the standard staple sizes available that you might find in market space. So if you have an application that have one of these top sizes, then you can use this product as an option in your HVAC application. As far as for filter availability, that's a big situation today because there's a big run today on a lot of customers wanting high efficiency filters in order to open up their businesses, because in many states and jurisdictions, they are requiring a minimum filter efficiency level and higher. Some of them are saying you must meet MERV 13 and higher. So it is putting a fairly substantial run on filters of that type. To give you an idea of where we currently stand on our filter availability, MERV 8 filters, both in our self-support and our wire-back HE40, is available in the standard lead time of 5 days. MERV 11 pleated filters have a standard lead time of 10 days. On MERV 13, we are seeing a large amount of demand for that product. So as of this time, pretty much our filter capacity for production is currently allocated out to customers for the next few weeks. So for availability on that product, I would suggest that you would contact your reps or sales contact to find out what current availability would be on those products. For Advantage, MERV 8 through MERV 16, that standard lead time is 15 days. And then in depleted Parker Load Tech filters and quad seal, the high efficiency MER 14 filters are also 15 days. For applications where you might run into or serving hospitals, might may use HEPA filters. HEPA filters are currently sitting at 15 to 20 days on a lead time. One thing you must remember is that logistics, which is going to be the amount of time it takes to ship the filter from our location to you, can add 3 to 7 days to that arrival time from shipment from our location to delivery. So you need to go and make sure that that logistics time is added into your delivery dates when you're talking to customers. So for contacts and details, you can talk to about our products. We have numbers here for customer service, both phone number and direct email. Email also for the Parker HVAC Technical Services team. So if there's an application that you have questions on and would like to get some ideas on filter recommendations for it, you can email to hvactechnical@parker.com. And we also have a web portal available at parker.com and also at the link below, which is discoverparker.com COVID-19 HVAC, for additional information on our products and how they can be used to help reduce the threat of airborne infectious transmission. And for your organization's business development manager is Guy Moret, and his email is at the bottom of that page.